Hello everyone. I'm Yan Song Zhang. I'm do the first part of our final presentation. Our project name is Infiltration and Data Exfiltration Bot. As you can see, this is our project name and our group member, their names and student ID. Now I'm going to talk about Scrum meetings and the procedure. Our Scrum meeting were quite effective overall. Each stand-up helped us stay aligned on weekly goals and quickly identify blockers, especially during module integration. The short focus format kept discussion efficient and everyone uh, clearly understood their tasks after each meeting. And for the procedures, we followed Agile principles well. We use weekly sprint task boards and consistent review sessions. Each sprint had clear deliverables from W1 to W6. Uh, the iterative process helped us integrate modules smoothly and detect the issue early. Having short review retrospectives at the end of each sprint also improved our coordination over time. And next one, I will talk about what we did well in our project. We did well in task ownership, sprint planning, and modular development. Each member clearly understood their part: scanning, exploitation, filtration, or reply, and delivered on time. Our documentation and testing practices were also strong, which made the final integration much smoother. What we need to prove, we think we can improve on time management and testing synchronization. Some delays during final integration phases because some different components complete in slightly different times. We plan to add buffer time for integration testing before sprint reviews and using performance metrics and data-driven files in the future retrospectives. And finally, our team communication was overall positive and professional. We used group chat and WeChat actively, which kept everyone informed. The main challenge was coordinating across different technical focuses. For example, when linking the exploit module with the Excel pipeline, we learned to document interface changes early and schedule quickly sync calls to avoid confusion. In summary, Scrum process provides strong structure, teamwork, and consistent progress. Most objectives complete and fully integrate system test on end to end. In the future, we focus improve time and coordination, strengthen cross module communication, and maintain agile, modular, and adapted workflow.
Okay. Hi everyone, I'm Wei Liu. I'll walk you through our requirements, how we collected them, what changes, and how we responded. We gathered our requirements from two places. First, the official briefs. They told us the key rules. We only have a 2-minute window. The target IP comes on ARC1, the output folder is ARC2, and we must prove the correct NOC list and matching photos while avoiding decoys. There's even a 68-bit hash fragment to confirm the real NOC file. Then we had client Q&A. The client asked us to write our own scripts, allow AI-only ad support, keep a GUI, and focus on a clean, low-noise pipeline. Later, they suggest single-thread password guessing and not to chase a specific Jellyfin CVE. They also warned the NOC file might need processing to review it. So, did we get everything early? The big rules were clear from day one. The finer points are one for IP, password first, single thread, and the encoded NOC. They were clarified during the project. Were there major requirement changes? Yes. We unified input to ARC1 for the target IP. We shifted strategy from find one special CVE to password first with single thread exploitation for low noise. We also assumed the NLC file might be hidden or encoded, with many decoys on disk. So, how did they impact our project? Those changes shape our build. We moved to a state machine with low noise, sequential logging attempts, and we repurposed concurrency for the safe part, file validation. In our Titan run, the bolt quick hashed 13,234 files with 16 threads, and we did log into Jellyfin with admin password. The run finished in 187.71 seconds. And how did we handle all this? We unified the CLI, keep the flow from detect, access, validate to X5. And then we use the 68-bit hash fragment plus priority sorting to avoid decoys. So this is our story. We have clear rules, some late clarifications, a design built for low noise, and a pipeline that already works ends to end. The next iteration is about precision, finding the correct NOC list and photos within 2 minutes while staying quiet. Thank you.
Hello everyone, I'm Hao Mingchen, and I will introduce the part 3. Our group's definition of done is that the task fully satisfies the user story or feature requirements as defined in the project backlog or specification document. All necessary code has been written, committed to the repository, and pushed to the main branch, or merged via pull request. All new code has associated unit tests with at least 80% coverage, and all tests passed without failures. At least one other team member has reviewed the code, provided feedback, and approved the changes. The feature works as expected when integrated with the rest of the application, with no breaking changes to existing functionality. Relevant documents such as README, API docs, or inline comments has been added or updated to flag the changes. If applicable, the changes has been deployed to the staging environment and verified to function correctly. There are no unresolved bugs, code smells, or technical debt related to this task. The team has agreed that the task is complete during our stand-up or retrospective meeting. At the beginning of our project, we pushed the code to GitHub as soon as it was ready. However, we did find that the bug would delay the project's progress, so we added a review step to the definition of done. Now about our tools. For communication, we use Teams for asking questions and gathering feedback from our client, Zoom for those detailed technical meetings, and WeChat for quick daily updates. This combination keeps our 6-member team perfectly synchronized. For development, we stuck with VS Code for coding, GitHub for collaboration and version control, and Docker to make sure everyone worked in the same environment. Nothing too fancy, but exactly what we need to build and test our board efficiently. These tools help us stay coordinated and maintain code quality throughout the project's development.
Hi, I'm Shanglin. I'll demonstrate the testing part of our project. Our board is mainly uploaded to the Titan platform for scoring, but we've consistently gotten 0 points, sometimes even -700, -300, or -100. Besides Titan testing, we used a multi-level approach. Unit testing for individual functions, integration testing for module interactions, E2E testing for the full workflow. For example, in unit tests, We verified the core functions like hash calculation and file verification by feeding them bulk data and checking outputs against the expected hashes. Integration tests combined modules, such as testing the Genevieve authentication attack with the file search logic to ensure seamless data flow. Our E2E tests simulated the entire bot run detecting the target IP, exploiting vulnerabilities, exfiltrating data, and cleanup. Did we use test-driven development? No, we didn't. Our process was code first, then test. If we didn't use TDD, would they have worked with our process? Probably not. Our project involves dynamic elements like network scanning, real-time exploitation like FTP, SSH, Genevieve APIs, and handling unpredictable data formats. Writing tests first would have been challenging because we often needed to run the code against a live target to understand behaviors like path traversal or concurrent file caching with a Thread Pro executor. TDD works best for predictable, isolated logic, but our bot's adaptive nature made it hard to define failing tests upfront without exploratory coding. That said, TDD could have helped in modular parts, like the hash verification function, to catch edge cases earlier. Do we feel our process adequately tested our program? Overall, yes. It helped us identify and fix issues locally. For instance, our tests caught bugs in file processing, like handling base64 encoded content or image filters. Were there 10 bugs got pushed down GitHub? Yes, a few times. For example, an early version had a bug in the concurrent threading for file scanning, causing timeouts that weren't caught until integration testing. These were pushed because we tested post-commit. Better testing like mandatory pre-push unit test via Git hooks could have caught them earlier, preventing dirty code from reaching the repo.
Hello everyone, I'm Ming Kun, and I'll talk about our team's progress and the documentation. At the beginning of the project, the progress was quite slow because we spent time fixing setup and the packaging issue. It took a while to make our code run properly in Titan environment. From Scrum 2 onwards, our workflow became much more stable. We start using GitHub project board to track tasks, and each sprint end with clear goal and results. We also rotated a Scrum Master role, which helped everyone understand the process and improve our cooperation. Instead of the long weekly meeting, we held short, focused check-ins to identify blockers earlier. That keep our stable and help the team finish each sprint on time. Our documentation style was simple but useful. We keep notes close to the code instead of writing long reports. Each mod has its own README file, and we use clear commit message to record change and decisions. After each sprint, we summarized what worked and what failed, so we could reflect quickly. If I could restart the project, I'd add a small dashboard to show our velocity and the issue trade out automatically. That would make our review more data-driven. Overall, our progress tracking and documentation help us stay organized, communicate clear, and deliver consistency.
Hello everyone, I'm Zixuan Li. My topic is software analytics and reflection. So let's start with analytics. In our project, we believe there are a few circumstances that could have led to better code quality. The first is smaller pull requests. When each change is small and focused, reviewers can understand it faster and catch mistakes earlier. Large pull requests take longer to check, and it's easy for tiny issues to slip through. Keeping pull requests short would have made our workflow cleaner and debugging easier. The second is familiar reviewers. When someone who already worked on a model reviews the code, they understand the structure and can give more accurate feedback. It also keeps the style and logic consistent across the project. If each part of our system had been reviewed by its original contributor, so we may have avoided some later debugging work. Now, if we had the chance to analyze our project data, here's the question we explored. If we could perform data analytics, we explore one question. Do smaller pull requests lead to fewer bugs and higher Titan scores? To find out, we analyzed data from GitHub, including pull request sizes, bug logs, and project results, to see if there's a clear pattern. So based on our experience, our hypothesis is that smaller pull requests and familiar reviewers make the code more reliable and efficient. In reflection part, I will share strengths and weaknesses from our team and what we plan to improve next time. So let's start with strengths. First, we have well-structured meeting management. We met every week for about 1 to 2 hours with a clear agenda, checking progress, reviewing tasks. Even when debugging took longer, the structure helped us stay organized and focused. Second, we have rotating leadership and clear role. Across the 5 sprints, the leadership rotated. Each of us also focused on different technical parts like network scanning, validations, and file exfiltration. So this gives everyone a chance to practice leadership and know how exactly what they were responsible for. Third, we were proactive in candid communication. We asked detailed questions, and those answers really shaped our design. For example, when we asked about Jettifying, the tutor told us not to focus on complex CVE attacks, but to use a simple password brute force approach instead. That one clarification saved us several days of work and kept our design island with project requirements. Now for the weaknesses. First, debugging often made our meeting run too long. When we hit an issue, a 1-hour meeting turned into 2.5 hours. Everyone stayed watch, but it became tiring and left less time for planning. So next time, I think we will use parking lot rule. If an issue takes more than 10 minutes, we will record it and fix it offline. Second, the technical workload wasn't evenly shared. For example, the SSH model was mostly handled by 1 or 2 members. When changes were needed, others weren't confident enough to modify it. We plan to use pair programming next time so more people understand each module. Third, we have some communication gaps and time pressure. We use WeChat, Teams, and GitHub at the same time. Before submitting to Titan, one member pushed a fix on GitHub, another shared result on WeChat. So 2 people ended up working on the same bug without realizing it. In future, we'll make GitHub our single source of truth for all final updates. Overall, this project taught us a lot, not just about cybersecurity, but also teamwork, time management, and communications. We will keep our good structured and improve the part that slowed us down. Thank you for listening.